In this video, I'll be going over 3.3 guided notes, and we'll be finishing up the last section of these notes. Over the past couple of days, we've learned how to find slope. First, we learned how to find slope if we were given a graph, and we calculated the rise over run. Then we learned how to find the slope given 2 points, and we used the slope formula for that, which is change in y over change in x. Today, we're going to be taking a look at tables, and we're going to be figuring out how to identify a rate of change given a table, and then finding the slope based on that information. So if you're handwriting your notes, the title of today's short notes will be finding slope given a table. And this is the third strategy we're going to be covering for now. So when I talk about a table, what I mean is a table of values. For example, what you see over here. We have x and y, and then we have different values. These values represent coordinates. So for example, we have -1, 9. That's actually a coordinate at -1, 9 that you could graph. And all of these are coordinates. So if we're given a table, we're going to take a look at these steps. Step 1 is to make sure all the data is linear. Okay, what that means is that we're looking for a consistent rate of change between all x and y values. Alternatively, we can graph the points to make sure they form a line. But the first thing, sometimes we're not just going to be asked to find the slope or the rate of change given a table, but we're actually going to have to identify if the data is linear. Linear meaning that it forms a line. So what we do is we check the change in x and we check the change in y, and then we're looking for a consistent rate of change. So let's walk through what that looks like. So on this first one, what I'm going to do is with the x values, I'm just going to find what is the difference between this first x value and the second x value. Well, to get from -1 to 1, that's a +2. -1 plus 2 gets me to 1. And then I want to look from 1 to 3, what do I have to do to get there? I also +2. And then finally, to get from 3 to 5, what do? That's a +2. So you may have done charts similar to this, even in elementary or middle school, but we're identifying the rule essentially with the x values. How are the x values changing? And so far, I do see a consistent pattern, +2, +2, +2. So now I want to check the y values and see if they also have a consistent pattern. So over here, what do we do to get from 9 to 6? Well, it's -3. What do I do to get from 6 to 3? That's also -3. And finally, how do I get from 3 to 0? -3. So it does look here like we have a consistent rate of change. Both x and y are changing at constant or consistent intervals. So the answer would be yes, this data appears to be linear. In order to then define the slope of the line, that's what brings us to step 2. For step 2, we're going to divide the change in y by the change in x. That's what I just did. I found this is the change. Remember that symbol, that triangle symbol means change in x. And what I found over here was the change in y. How are those values changing? Well, the x values are changing in a pattern of +2, and the y values are changing in a pattern of -3. So if we refer back to our notes from yesterday, we know we can find slope by looking at change in y divided by change in x, because that is the same thing as finding the rise over run. So I'm going to use that information to find the slope here. The slope of this line, m, equals change in y over change in x. My change in y is a -3, and my change in x is a +2. I don't have it listed on here, but as we've been practicing, we want to make sure that that's in simplest form. -3/2 is fully simplified. So that's my slope, or my average rate of change. We could graph these points and verify that, and I'll do that quickly. I want to make sure my x values range from -1 to 5. And then I want to make sure my y values range from 0 to 9. Then I'm going to plot each point. -1, 9 is way up here. Then I have 1, 6. 3, 3. 5, 0. And if we were to connect these dots, we would notice that yes, these do appear to be linear. And specifically, I can use my slope pattern, which is, it's negative, so I'm going down 3 over 2. I can check that. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. 1, 2, 3 over 2. So yes, everything does match here. This is linear, has a constant or consistent rate of change. The slope is -3/2, and that's what the line would look like. Let's check this second table. We're going to use the same process. We're going to first check and see if this data is linear. Starting with the x values, I'm going to look for change in x here. How do I get from 0 to 1? That's +1. How do I get from 1 to 2? It's +1. How do I get from 2 to 3? That's +1. So far, it looks good. The x values are increasing by +1 each time. Now let's take a look at change in y. To get from -2 to 0, that's a +2. To get from 0 to 1, that's a +1. And to get from 1 to 5, that would be 4, +4. Are these changes consistent? No, we're not changing at a constant rate with the y values. Whoops, that kind of drowns out what I wrote. These are not changing at a constant rate. So what that means is we actually don't have a constant rate of change. We can't find a slope. There's going to be a different slope between each point. If I divide this change in y by this change in x, I'll get one slope. If I do this change in y divide by this change in x, I'll get a different slope. And if I divide 4 by 1, I'll get a totally different slope. And so this is not going to form a line, and we can see that in just a moment when we graph this. So I'll go ahead and set this up. My x values go 0, 1, 2, 3. My y values go all the way from -2 to 5. Okay, so I'm going to plot 0, -2. It's right here. 1, 0. So those points seem to form a line. But then let's look 2, 1. It's not in the line. It kind of starts to flatten out. And then 3, 1, 2, 3, 4, 5. Obviously, that is not in a line. So if you were to connect these dots, there's a couple ways you could do that. We could kind of fill them in with a curve and show this is not linear. Or you could see that there is a slope between each of these points, but we do not have a consistent rate of change or a constant slope. So this is not linear. Something that I can do, though, and that we're going to be working on with some application problems today, is I could be given data that looks like this, and then I could be asked to find the average rate of change. If we're talking about the average rate of change with some values like this, what it's asking is, from my starting point to my ending point, what is the slope? So once again, we'd go back and we would use the same information from yesterday. I can just identify my first point and my last point, which is 0, -2, and then 3, 5, and then I could use slope formula to solve. So in that case, if I wanted to find my average rate of change, I'll write that down, average. That's your first to last point. How we would do that, we're going to use the slope formula. Slope equals, my y value here is 5 minus -2. And then I have 3 minus 0. I subtract here, minus a negative becomes plus. 5 plus 2 is 7. 3 minus 0 is 3. So my average rate of change with this data is 7/3. That can't simplify. So if it's asking you for an average rate of change, even if it's not linear, in that case, you would just take your first point and your last point, and you would find the slope between those points. So that brings us to our practice for today. We have already practiced finding slope on graphs, finding slope with points, and today we're going to get into some application problems. So let's take a look at this first one. If you were writing these notes by hand, just kind of draw a line under those notes and write 3.3 application problems. It says a climber is on a hike. After 2 hours, he is at an altitude of 400 feet. After 6 hours, he's at an altitude of 700 feet. So before I dive into the prompts and questions here, I like to reread if it's a word problem and see what, the first time I just read to figure out what's going on. We've got a climber and he's climbing up because he's climbing, and altitude means his height, and that height seems to be increasing. But let's now, the second time I read, I'm going to pay attention to the numbers I see. A climber's on a hike. After 2 hours, so we're dealing with time, he is at an altitude. Altitude means height. He's at a height of 400 feet. And then after 6 hours, he's at an altitude of 700 feet. So I've got time and I've got altitude or height. So it says, predict the rate of change, altitude over time, described by this situation. Then it says plus, minus, 0, or undefined. So this gets back to what we did on the very first day of this week, where we were just trying to figure out what direction is this line going? Well, if I just think about it, time is passing. If that's our horizontal axis, time is passing, and this guy's height seems to be going up. He's at 400 feet, and then he's at 700 feet, so that seems to be going up. So that is what I'm going to write here, predict the rate of change. It's increasing, which means the rate of change, remember, that's kind of another word or idea that represents slope. It's going to be positive. That's my prediction. Then it says create a table of values to show his altitude in relation to time. So that's the two things we're measuring, his altitude or height and the time, starting with t equals 0. So I gave you a graph to work with on these examples down here. So basically, we're just going to fill this in with the information that we were given. So it says start with t equals 0. Well, in the problem, it didn't tell me his altitude at 0. So for this situation, I'm just going to assume that his altitude was measured from a starting point of 0. Then it says time, and it's measured in hours. And what's the altitude then? So the next time that we check in is at 2 hours, and he has an altitude of 400 feet. So at 2 hours, he has an altitude of 400 feet. And then after 6 hours, he has an altitude of 700 feet. So the point there is 6, 700. Great, so I just filled in my table. So I did this next part. Then it says identify the rate of change between each set of values. That's what I just did on the notes today, where we're looking at the change in our x and we're looking at the change in our y. So to get from 0 to 2, how much time is passing? That's 2 hours. And then to get from 2 to 6, that's a plus 4. So those x values don't seem to be increasing at a constant rate. Let's see what's going on with the y values. From 0 to 400, that's plus 400. And then from 400 to 700, that is a plus 300. So these also don't seem to be consistent. But I did identify that rate of change between the values, the change in x. Well, it's different. It's marked down there. I showed my changes right here. Okay. Is the rate of change constant? Explain this in the context of the problem. So as we just saw, no, the rate of change is not constant. Explain in context of the problem, well, it looks like we're checking in at different intervals of time. So he checks in at 2 hours and then again at 6 hours. Those aren't constant intervals of time. And then also when he is checking in, he has climbed different amounts. If we wanted to be even more specific, we could look at the actual slope between these two lines like we did before. We could divide or find the change in y divided by change in x and find the slope between each of these sets of data. But basically, my answer here is going to be no. He is not, just to say this simply, he is not climbing at a constant rate. And this could, if we're talking about context of the problem, it could be because some parts are steeper than others and he does them slower. Maybe he took a break to eat lunch or drink water. So that is what we just want to consider there is what kind of factors might be influencing that. So then it says graph the story. So I'm provided with an open graph here. And so I'm going to set it up to work for the information that I was given. All these values are positive, so I can kind of use the border here as my y-axis and then my x-axis. I'm not going to have to go anywhere negative because time can't be negative. Time is going to go on bottom, and time is being measured in hours here. And then the altitude is our dependent variable, and that's being measured in feet on the y-axis. So time is passing. We're measuring in hours, so I'm actually going to widen this out. I'm going to skip a line and so I don't crowd those hours together, and I'll start with, this is obviously 0, 1, 2, 3, 4, 5, 6. So I'll mark out time that way, just so my graph isn't so squished. I'm spacing those hours out a little bit, and then altitude is actually increasing quite quickly. We have to get all the way up to 400, 700, so I'm going to count by hundreds, but I'm going to do the same thing. I'm going to kind of skip a line in between to give myself a little bit more space. So here I have 100, 200. Okay, now we're ready to plot these points. The first point is 0, 0, which is down here. Then I have 2 hours, comma, 400, so he climbs up 400 feet, that's right here. And then at 6 hours, he's up to 700, which is, 6 goes up to 700, which is right there. I keep drawing a line. All right, if I were to connect these, I would see that, yes, this is not a constant rate. It's not a straight line. But my original idea that this would be increasing is true. It is moving in an upward direction. So let's move on to the next prompt. It says, what is the hiker's average elevation gain? Well, remember when I said if we're talking about average, it's just asking what is the slope or the change from the first point to the last point. So we can calculate this. So my first point, it was 0, 0. And my last point, or my ending point, was after 6 hours, he was at 700 feet. So we can use our slope formula here. Slope equals change in y over change in x. And actually, in this case, I've got to be careful when I did my example way up here, because, never mind. I was thinking up here that I used my change in x and y values from the table, but that's not true. So we can't use these values over here, these change in x and y values, because for those we were finding the difference between these points. We actually want to find the difference between the first and the last. So I'm going to use y2 minus y1 over x2 minus x1. So y2 would be 700 minus 0 goes on top. And then I have 6 minus 0 on bottom. Well, 700 minus 0 is just 700. 6 minus 0 is just 6. These should both be divisible at least by the number 2. Giving me 350 over 3. So what does that mean? Well, it is positive, as I predicted. But what this means is, in terms of my problem here, is that for every 350 feet that he's climbing up, that takes him 3 hours. So that's how we can interpret. That's his average speed. And what I just found was this line right here. So if all we knew was his starting elevation and his ending elevation, then we would assume that he was increasing at a rate of 350 feet every 3 hours. All right, so that brings us to this last question, which says, if the hiker continues to climb at the same rate, which is 350 feet per 3 hours, how high should he be after 9 hours of climbing? So this just takes my interpretation to the next level. It's basically saying, okay, let's check in at hour 9. What is his altitude? Well, we have inconsistent rate, but that's why it said use the same rate. So we're going to use this rate of 350 over 3. So my change here, getting from 6 to 9, how many hours is that? That is a plus 3. So we know that every 3 hours he's increasing 350 feet. So from that ending point, 700, I can just add 350. So what I'm doing here is from 700, 3 hours are passing from 6 to 9, which is what I'm looking for, 3 hours. Every 3 hours, he goes up 350 feet. So if I add 350 here, I should get I get a value of 1,050. So he should be at a height of 1,050 feet. That's what I would expect. One thing I want to point out that you may encounter, usually this actually just came to mind because this would not work if I said if the hiker is climbing at the same rate, how high would he be after 10 hours? Obviously, to get from 6 to 10, that would be a plus 4, not a plus 3. So this would be a little bit more difficult. When we're trying to find average rate of change, we usually are keeping our answer as an imperfect fraction, like I did here, 350 over 3. But we can go ahead and divide that out and get a number. So if I were to take this one step further, I just plugged in my calculator 350 divided by 3, and I got the value 116.6666. So I'm just going to say 116.7. I'll round that to one decimal place. And we can actually write this as feet per hour. what I did there was I divided by 3. So this is going to tell me how many feet per 1 hour. So that way, if it was asking me to find his height after 10 hours, I could do that. I would just add 116.7. I would just add that 4 times. Or in this case, if I wanted to find after 3 hours, I would just add 116.7 3 times. So let me show you that, because you may be asked to do that on some practice on your own. So if you go ahead and divide that out, you're going to get your feet per hour, or whatever your units happen to be. In this case, I was just able to think through it because my rate was in terms of 3 hours. But alternatively, you would start with, so 700 was my last point, and then from 6 hours. So then I would add 3 hours have passed times 116.7. That's how many feet he's going up per 1 hour. And then I would get my value, and I should get the exact same thing, maybe a little different just because I had to round that number. So remember, use order of operations. I'm going to multiply first 3 times 116.7 gives me 350.1, like I'm off just a little bit, and then plus 700 is 1050.1. So I could just round that to 1050, which is the same answer I got before, just using a different strategy. So that's what you may need to do if your points, if your rate of change is not expressed out of the denominator that you want. So now your task is to, I have several different situations here. There's one about a scuba diver, one about a savings account. There's one about airplane travel. There's one about weight loss. Your job is to pick at least one of these other situations and to answer all the questions on your own. You need to choose at least one. So that's what I'm looking for you to submit on Canvas, is just one of these other situations. You need to walk through the steps just like I did on this example, mark it up, show your work, answer all the questions. And what you're submitting on Canvas today is your work on one of these other questions. If you'd like to do multiple, just for practice, it's definitely going to help you and benefit you. So I recommend, you are welcome to do that. I may even give bonus points for that. So if you do more than one, that would be amazing. But the expectation is that you're doing one other application problem and submitting your work on Canvas by tonight.